Hello, and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices all the way to cloud services and everything from an IoT Builder perspective. It is June 21st, and this is episode 33 of our weekly live stream. My name is Alina Dima, and I'm a senior developer advocate in the AWS IoT service team. In this episode today, we are going to be talking about KVS, and joining me today to do so is David, Specialist Solution Architect for KVS with AWS. Hi, David.
Hey, good morning, good afternoon, Alina. How are you today?
I'm very good, thank you. What about you?
I'm doing well, thank you.
Very good. So, David, can you briefly introduce yourself for all our viewers?
Yeah, I'm a specialist solutions architect here at AWS. I've been with the IoT specialist team for a couple of years now here at AWS, and just recently started specializing a little bit more in Kinesis video streams. So I help customers build connected camera devices or work with existing IP cameras, for example, to obtain their media, stream it to the cloud for playback and analytics.
Oh, that sounds really interesting. So in the live stream today, we are going to learn a lot from David on KVS. So maybe, David, to get us started, could you tell us what KVS is and maybe, a bit of what one can do in terms of streaming with KVS?
Yeah, absolutely. It might be helpful to talk about this in terms of a quick picture. So let me go ahead and share something here.
Sure.
Yeah, so Kinesis Video Streams is a service that was actually born out of the needs identified by the Amazon Go stores that were being built, where they had lots of cameras in the ceilings and they needed to ingest video from those cameras and then use the media that they obtained from that to build the ML capabilities that drive that, hands-free checkout experience that they have there. So Kinesis Video Streams was the first product that was released by AWS, and it's designed to help with the secure ingestion, as it says here, from really millions of camera devices. So it automatically scales and allows you to securely ingest media from your video devices. But if you can kind of see from the arrows in this diagram on the left here, it is really one way. So it's designed to help you take media from camera devices and stream it to the cloud. And then, of course, play back that media, build video analytics type solutions, custom video processing on top of that, and so on. So later on, they released in 2019 WebRTC support for Kinesis video streams, and this includes bidirectional, low latency, peer-to-peer support for camera devices. Think of things like baby monitors and video doorbells and pet cameras, where you not only want to be able to bring up that very live feed from your video device, but also perhaps you want to communicate back to the person on the other end, right? So again, that peer-to-peer bidirectional streaming of media is what WebRTC really enables here.
Mm-hmm. Okay, that's actually really cool. So why is it that we actually need to do this on the cloud side? So why is it not enough to have the cameras, deal with images and the videos?
Yeah, I'd say that's a fair question. So just for one, WebRTC, for example, in order for the devices to communicate with one another, say that you have a mobile application and you're on the go, and this happens to me all the time, right? I've got my video doorbell. My kids' friends come over to say hello. I get the doorbell notification on my phone. It's easy enough to just pull up the stream and respond to them, hey, like, we're not home right now, come back in an hour. My kids will be available to play then, right? Like, you can easily imagine the type of experience that you have there. Without a cloud-based service, it's difficult to then build that sort of thing. It's not impossible, but you'd have to put in a lot of effort to manage and deploy the sorts of solutions that we have here. And these aren't easy types of services to build and implement for yourself. So what KVS for WebRTC provides is those managed signaling stun and turn services that are needed to help build that kind of interaction in the cloud. And of course, it's available as a globally deployed service, available in multiple regions around the globe. So it's easy to also pick that up and target different markets with products that people want to build. From a streams perspective, it may just be that at the edge, there's a lot of intelligence applied on the camera itself. And this is pretty common in connected home as well, where you have a video event that's triggered by maybe your camera device has an on device sensor, like a PIR sensor to detect motion. Or maybe there's constant evaluation of the frames themselves on the camera where they're looking for that kind of motion to basically indicate there's something going on here. There might even be some ML capabilities on the camera itself as well to run inference locally to determine, was this a person or did a leaf just blow by, or was the wind blowing and making my trees cause motion, again kind of triggering that motion sensor. But that would either way result in maybe just a short video clip using a rolling buffer that's on the camera itself to get kind of a couple of seconds leading up to the event, recording for like a minute or two, and then sending that up to the cloud for later viewing. Now, what Kinesis Video Streams provides kind of above and beyond some other services that you could use for storage and compute, it's also indexing that media and making it very rapid to go and obtain. It's also allowing you to set a kind of storage lifetime for that media. So you can easily build a subscription type service that says, hey, this customer is on the free tier. They only get to have 7 days total of storage. And the service automatically takes care of that. And then on the playback's capabilities perspective, this is where KVS does some things that I think are really great for helping developers really build the type of experience that they want to provide to their end customers. The media that goes in can then be easily played back via HTTP live streaming or Dash session URLs. And that's just makes it very easy to build a mobile app that can just play that media. I don't have to worry about transforming it. I don't have to worry about building custom video players. Like it's very compatible in the mobile ecosystem to just readily play that sort of video back that way.
I see. So it's basically from the edge, from the camera into the cloud, and then from the cloud really fast streamed into an app or a web interface or a web application.
Yeah, correct.
Super interesting. What kind of latency are we talking about? What is, first of all, the latency of, let's say, ingestion of the videos, but then also usually the latency of streaming them out into apps?
Yeah, so definitely a consideration. End-to-end latency has to do with a couple of things, but actually, let me switch over to another. There's a whole bunch of things I could talk about here. But when we talk about streaming the media through, we provide a number of SDKs that can be installed directly on camera devices. And for Kinesis Video Streams, not WebRTC, we have what are called these producer SDKs. And these SDKs give you some parameters that you can tune that control the rate at which the video is streamed. So if that rate is slower, then obviously it's going to kind of slow down the rate at which the media arrives in the cloud and then becomes available for playback. Then as you look at your web and mobile applications, there's some characteristics that video players have that try to deal with this network streaming and the various conditions that can occur as part of that. So it's very typical both on the camera device and on the video player itself to provide some buffering, which also appears as some kind of latency end to end. So I'll show you a quick demo. I have an IP camera permanently installed in my front my front yard, so I can do some basic monitoring and also make it easy to demo Kinesis Video Streams. So typical, without tuning this, without thinking about it, typical latency is around 3 seconds, 3 to 5 seconds. So pretty good without having to do anything. Again, I've got pretty good networking conditions, and I'm even doing an ingestion from an IP camera on an EC2 instance. So it's actually adding a hop up to the cloud to consume the media, and then everything's within the AWS backbone at that point. But then WebRTC, your time to first frame, so how long it takes to connect and get the media flowing through, is typically around 1 to 3 seconds. Again, depends on the network, some of the other decisions that are made by the camera application and how to initially send that first frame. Sometimes cameras will send like a reduced quality first frame just to get the media flowing. And then if the network seems stable enough, it will upscale the video and send higher quality video. So that's a common technique used in building camera devices. But then from there, end-to-end peer-to-peer latency, which I'll demonstrate with WebRTC and this little test camera I have set up here, under 1 second, right? So sub 1 second latency is very common for end-to-end continuous transmission of the frames and the media.
Oh, that's actually really pretty good without having to actually do any sort of fine tuning. That's actually really good. Yeah, I mean, I think before we actually go and see the demo, I wanted to ask you, what are the most interesting use cases that you see AWS customers building using streaming and using WebRTC and maybe using machine learning?
Yeah, so I have customers, as I've already mentioned, in the connected home space, customers building more of the classic surveillance type solutions, and that can span anything from enterprise surveillance to, again, home surveillance or small business surveillance. So that has categorically some slightly different aspects to it than just a directly connected camera. But I am seeing today, we have quite a few customers that are coming through in the automotive industry as well, where vehicles today have multiple cameras on them. People want to either just be able to bring up a live view of that, maybe even communicate with someone that might be walking too close to their nice car, tell them to kind of back off. But the other really cool use cases that I've seen pretty recently in automotive also include the ability for autonomous vehicles to be remotely controlled. And again, they need the low latency live view from the cameras that are coming, so using WebRTC. But then there's another feature of WebRTC called a data channel, and that allows them to send these commands bidirectionally to and from using that same peer-to-peer connection alongside, it's in a separate channel that kind of runs parallel to the media itself, but it allows the commands to be sent again over that peer-to-peer network, very low latency, very quick. So it allows them to build these kind of remote control applications to remotely control the vehicle, maybe pull it off to the side, look at the cameras, see what's happening, communicate to the driver or the passengers or whatever that might be, just to kind of see how things are going. So WebRTC is being used in some very interesting ways recently that I've seen.
Okay. Yeah, that's actually super cool. I mean, I think in the autonomous driving space, it's particularly interesting. All right, so maybe before we go on with more questions, maybe you can show us the demo. I'm really curious to see what you have in store for us.
Yeah. So just to start out with, what I've got a couple of devices that are just pre-configured. This is just the Raspberry Pi. With a nice case. Adafruit sells some nice like pre-printed boards to make this kind of vertically mounted. The new Raspberry Pi cameras. So in particular, I think this is the HD camera. Anyway, I've got a couple. I keep swapping them out just to do different things. And I have the KVS WebRTC SDK for C installed on this camera device. And so just really in a few minutes, you can clone the GitHub repository for the C SDK, install it on something like a Raspberry Pi or an NVIDIA Jetson like Nano board, anything with a camera directly attached. And you can easily take the frames directly from that or use a media framework such as GStreamer and obtain the media and transmit it through the WebRTC connection very easily. So I have that camera running right now. Let me go ahead and share my screen so you can see the AWS console, and we'll go look at a few things together.
Perfect.
All right, so just to start out with, one of the most basic aspects in the AWS console for Kinesis video streams, I mentioned there's the two streaming methods. There's video streams, And then there's signaling channels. This is really what you're going to use to find your WebRTC enabled devices and connect to them. Signaling channel, this is really nominal. You can name it whatever you want. I just have my test device connected to a channel named test. And right in the console, there's a media viewer that will connect as a peer just to kind of bring things up. So this will take just a few seconds to initialize the connection, get the media flowing through it. And then once it's actually connected, you can view some interesting statistics around the actual media that's coming through, such as the bit rate of the stream. I can view the video codecs that's being used, the resolution that's being used, actually the protocol. So this is another interesting aspect of WebRTC. It can use UDP or TCP. UDP is preferred for streaming media, just to, again, transmit the media as quickly as possible. There's another thing I can check, like whether or not I'm using turn. And then I'm not using or transmitting any audio here. So you can see no audio is coming through. If there was, I'd be able to, play the audio right here. So this is a quick way to get in and quickly test your device using the AWS console.
Mm-hmm.
And this is just pointing out to my backyard. So
Nice.
yeah,
Lovely view.
yeah, thank you. It's a fun place to hang out. The other thing we have a JavaScript SDK, and there's a hosted web page, which is the JavaScript SDK has an example application, and this helps developers get quickly up and running with building their own integration into their own applications. So this test page really just expects that you have an AWS Access key pair that you can use with the necessary access rights to get into your account. And then, of course, you need to point to the right region. It allows you to test a couple of other aspects and get a little bit more down into the weeds in testing things. So, for instance, I can, in WebRTC, the peers are going to attempt at first, if you configure your apps this way, to connect directly to one another for the lowest latency possible connection. But if there's, for some reason, something going on with the network, such as asymmetric NAT issues or firewall issues or whatever the reason might be, there is a cloud-based relay server, and that's what Turn is, that the devices can fall back to, and they'll still relay their media to one another. So it still allows them to connect. And so here I can test multiple NAT traversal options is what they're called in this. And I can also test a couple of other features. Trickle ice. Ice is one of the technologies that's used in a WebRTC connection. It's basically how candidates are exchanged with the two peers over the signaling channel. So they try to accumulate all of the possible IP address pairs and port numbers that they kind of know about, and they send those as messages to one another. And then once they have that information, they'll try that direct peer connection. And if that doesn't work, they'll try to connect through Turn. And that whole approach is all completely configurable in your application. Trickle ice allows all of the exchange of each of those candidates to happen asynchronously. If you don't use trickle ice, each peer will aggregate all that information synchronously before then sending it all over. So it causes a slower time to connection because it's aggregating so much information, sending it all over synchronously, and then each of the peers synchronously try each one until they find one that actually works. So trickle ice is something that we can do that speeds things up. The other cool thing I want to call out is some of my colleagues on the Partner SA organization have been working on this new device qualification program update for devices that appear in the Amazon device catalog. So we have an IoT device catalog, and in there are devices that are pre-tested and confirmed to work with AWS services. And so they're working on adding KVS WebRTC devices that can just work with KVS WebRTC out of the box. So they added this test into the viewer application. This is pretty cool because it shows you a lot more metrics about the connection as well. So let's go ahead and click Start Viewer. So if I'm using this page, connecting to my device would be connected as what's called the master. and then multiple viewers would come in and try to connect to that particular camera as viewers. So as things are initializing, you can see some statistics are being aggregated, and I can see how long it took to get to the peer-to-peer connection, how long it took to initially decode the stream, some ongoing statistics that come from WebRTC has a standard set of statistics that they make available so that you can constantly evaluate the connection. There's plenty of tools to look at this, but some nice metrics that we can get right out of the gate. And again, more information about like what the current total round trip time is. And my peers are more than likely directly connected to one another right now, meaning on the local network, because my browser here is on the local network. My camera right over there is on the local network. So let's do one more test. Let's see how this looks when I go out to a turn server. So I reside in Florida, the US East 1 region, which I'm connecting to, where the turn server would be hosted in Virginia. So it's not exactly, across the street. Let's go ahead and force the turn server connection. Let's kind of see how that potentially impacts the overall latency of things. Spoiler alert, I think you'll find it's still pretty quick. So this is the kind of testing that I do when I'm trying to determine like what's going on, how would this be impacted, even if I had to potentially build a system that connects over to like a region in California or Oregon, US West 1 or US West 2, and how is that going to impact my overall round trip time. So round trip time is a little bit higher. My live view up there, still pretty low latency. If I just kind of wave my hand over here at the same time, you can kind of see like it's coming through in a really live, low latency way. So this is WebRTC.
Mm-hmm. Yeah, this is really cool. Of course, apologies because my internet connection dropped for about 3 minutes, which of course is the benefit of being in Germany and being live. Happens. Yeah, thanks a lot, David, for showing this. I mean, the stats actually look quite interesting. I mean, I've seen this before, so I have not totally missed the context. So that's nice. And if you haven't shown this yet, I would like to also see, the observability metrics from the Kinesis, AWS console view, so that maybe we can look at the stats there.
Yeah, for that, let's kind of switch over to streams. So this is WebRTC, and most of the metrics in WebRTC have to do with that peer connection. And so they have to take advantage of that stats report. And so that's what this is demonstrating here. Let's go to, so this is WebRTC. Let's switch over to streams now. And I have an EC2 instance that's running, and I have my RTSP stream is configured to allow access from this EC2 instance, and this is ingesting continuously into a KBS stream. This allows me to go and figure out what's been happening, and so this is, like I said, probably really just a few seconds behind current. I don't have a clock right in front of me, but coming through, oh, here it is. It's showing how live the actual feed is. I can kind of refresh this, and you should see somewhere between 3 to 5 seconds around end-to-end time, and it's doing a little buffering. I have pretty solid bit rates coming through. This is an HD configuration, so 4.0 megabits per second. You can kind of see the fragment duration setting I was alluding to before, like how frequently are these fragments being published to KBS. So it's really just publishing or streaming this once every 2 seconds. I can see the codecs and then, of course, the video resolution. From a monitoring perspective, each individual stream has metrics available to it so that you can monitor the health and kind of what's going on with this particular stream. So if I just go back to, I think I've been streaming this now for maybe at least 3 months. Well, one, you can see my camera was offline for a little bit. I think I was building something or switching something at that point. So let's just go to like the last month. One thing about the incoming bitrate, this is not just a straight line because the encoder that I'm using on the camera is a variable bitrate encoder. And so it's kind of making some decisions to kind of lose some of the quality over time. And that's why you're not seeing just a straight line. I could go and I could configure my camera with a constant bitrate encoder, which I had changed at one point, and it was just a straight line across the board. And then the other thing about the active connections, this is where if this kind of dips below 1, you would expect that your camera is not connected. And if I didn't explain this before, a stream is typically one-to-one to a camera device. So I would expect to see metrics on a stream by stream basis, but I can also see all up metrics as well. If I actually had multiple streams coming in, I would see account level metrics. I'd be able to see how many total devices are currently connected with their own put media active connections. That's like the really base level API for streaming the media into KVS is put media.
Mm-hmm. Cool. That's really nice. And to get started, so let's say that I would like to set up this demo that you have going on. Where do I start?
Yeah, so there is a workshop, kvs.workshop, not plural, but singular, .aws. And this will redirect you to the Amazon Kinesis Video Streams workshop. We've recently consolidated both the streams and the WebRTC workshops into one, and we have quite a few solutions architects worldwide that are contributing to this. Shout out to Yuma in Japan. He put together the original streams workshop. We've had, like I said, lots of contributors working on new content for this, including a lot of features that we haven't talked about today. But this will help you if you want to get started with streaming media up to KVS. You can get started with these labs, KVS streams. If you want to get started with WebRTC, there's some like high-level introductory materials to help you understand just the protocols and the concepts so that you understand that. And then you can get right into building and deploying the sample applications as well.
Okay, yeah. So this is a great point to get started. I have shared this this link, so for anyone who is interested in following, they can just start with a KVS workshop. Yeah, that's really good. And because I don't know much about WebRTC, I would like to focus a little bit more of our time today, if you're okay with that, in talking about WebRTC. And maybe we can start with the challenges of integrating WebRTC. So I've heard that it's actually not easy.
Yeah, WebRTC as a technology stack is fairly complicated, and let's just kind of switch over to something that talks about that, because I do lay all the complexity of this out here. First, WebRTC is really a collection of existing technologies, and it's not necessarily, it's something you have to build with. It's like a tool in your toolbox, right? It's not a complete solution. You still have to do a lot to, as I was talking about, monitoring the connection and thinking about how things can really go wrong. I mean, just look at the list of key concepts that you have to understand off to the right, just to get started with connecting the device. And the SDKs and the sample applications really do a great job of obscuring a lot of the detail away from you. But then if something fails, then you quickly have to become a WebRTC expert. So you have to understand, like, hey, at what point am I failing? Is it failing to connect to the signaling server? Is it failing to send messages across the signaling server, and which device, right? And if it's tried to establish the peer connection, why did that peer connection fail? And a lot of those details would only be on the client applications themselves. So this kind of quickly gets into the classic IoT space of, okay, I've got a device, it's remote, I now need to get some information off of it, whether that's logs or, some sort of error codes. How do I transmit that back out so that it's meaningful and easy to understand and operate as I'm building and deploying my applications that use WebRTC?
Mhm. Okay, and in terms of so basically from what you're saying, then it's a lot of different technologies, and it takes time to understand all these different technologies and how they play together, and probably you would learn it by experience, by just basically practicing and seeing problems and then solving the problems, and yeah, in this way. What are the so I know you mentioned some of the SDKs and some of the dev tools available, but generally, what kind of tools do developers use when they are working with WebRTC?
Yeah. So there's a couple of things that you could use. One is while I have this connection being established here, there's a couple of tools that are built into like the Chrome browser, because again, the Google initially open sourced and released WebRTC as a technology, and so they have some tools available. The stats that are being displayed here come from the standard WebRTC stats reports. But Chrome has this tool, WebRTC internals, that lists out all of the possible stats reports that are available on that current peer connection. So actually, it's interesting. We're using SteamYard for this broadcast right now, and this is picking up on the fact that we have a WebRTC session going on right now. So anyway, if I go back to this tab here, this is where I'm running the WebRTC connection to my device. I can look at all sorts of information about what's happening here. I could create these dump files that can be used to bring into other tools to kind of investigate what's happening. And there are some standardized tools to help with that. Even if you ask yourself, what were the ICE candidates that were exchanged as part of the peer connection? What's cool about this is it's going to show you which ICE candidates were selected, what's actually being used. On my last connection, I forced a relay through the turn server. And so I would expect to only see the relay as the candidate. And this is showing it from the browser side of things. It's not showing it from the camera side. But in the CSDK, excuse me, we do have a number of the stats reports implemented, and these things are, again, available. You can emit the same kinds of stats right from the camera device and get that information from the camera too. Yeah, let's look at, so as the peer is connected, you could look at the statistics graphs for the candidate pair. So if we look at, hey, what's actually happening here on that peer connection? So from my browser to the camera and back again. These stats are constantly being computed, and I can look at them for any sort of indicators of maybe there's a change in network conditions, and that could be indicated by things like packets being discarded. There's a couple of other stats too. Round trip time, always helpful, right? Keep an eye on that sort of stat to make sure that if this is spiking, then obviously the network is probably slowing down and maybe the application needs to change a little bit in response to that. Let's look under, there's one more stat here, a graph. Inbound RTP. On the video channel, there would be one for audio if audio is being transmitted, but it's not. Is there any network jitter? And you can kind of see, you'd expect that, right? I'm on a Wi-Fi connection on the camera. I'm on a Wi-Fi connection on my machine. There's going to be some network jitter there. There's a built-in jitter buffer to kind of handle this sort of thing. There's so much to know about what's happening in here. And there are some tools that are out there that help with this today. One is CallStats.io. This is a tool that's used to constantly monitor these kinds of statistics, and it has some intelligence built in already to help understand when something is going wrong so that you can then remotely monitor things and respond to those. So that's one of the types of tools that today at AWS we recommend other customers consider for their production monitoring of WebRTC deployments.
Mhm. Okay, and what would happen if someone's interested, for example, in some aggregated stats over multiple of these connections?
Yeah, that's again where someone like CallStats.io is going to help with that sort of thing. It's looking
Mhm.
at and aggregating everything across the board. Um, there is another repo. Let me see if I can pull it up while I'm talking at the same time. The WebRTC engineering team here, they have another repo that is called Kinesis Video Streams Demos. What's kind of
Mhm.
interesting about this, can you see that? Yeah,
Yeah.
they have this Canary folder, and in here they have some canaries that they run on the WebRTC CSDK. So, like I was mentioning before, the CSDK is emitting these metrics, and what they provide is the ability to then forward those metrics out to CloudWatch. And so, if you wanted to just use standard AWS tooling for monitoring and aggregation of those metrics, you could do that with CloudWatch. And this will again get you some of these other interesting metrics that you typically want to know. Some of the things that we were just looking at. And there's a whole deployment setup for what's being launched here. It's a little more complicated than just kind of setting things up. But this is one way that they're constantly also testing the SDK and making sure
Mm.
that things are working is through this component. And they open sourced this for anyone to be able to use as well.
Mm-hmm. Yeah, I already put a link in the comment section, so have a look at the Canary folder in the Kinesis video stream demos. Really nice. So David, what do you think the future of WebRTC is? Like where do you see improvements? Like what's next on the AWS roadmap, maybe if you can tell us anything about it.
Yeah. So there is a feature that is currently in preview for KBS WebRTC, and it is called WebRTC ingestion. It's actually something you can easily test right here on the test page as well.
Mm-hmm.
This converges the two feature sets that I've been talking about before. Um, as a preview feature, it's a little bit more limited in availability. It's only available in one region today, and I believe that's US West 2. And it's also has some limitations as the team is developing it and preparing it for GA. But what this allows customers to do is through a WebRTC peer-to-peer connection from the camera device, they can still store the media up into Kinesis video streams. So you would, on the back end, also configure a named stream, just like I showed before.
Mm-hmm.
And you could use just one SDK on a camera, being like the WebRTC CSDK, to handle both peer-to-peer connections and ingestion. Whereas today, if you want to both store your media and enable peer-to-peer, bidirectional streaming, you'd have to use both SDKs on camera devices.
Okay. So it's basically moving from having to use the two SDKs to just one.
Yep,
Nice.
exactly.
Wow, super cool. And I know that we had a brief conversation before, and you mentioned that actually WebRTC is being used inside Amazon as well. And you had some examples. Is any of that maybe, can you tell us anything about that?
Oh yeah, I believe that WebRTC is being used by other services as well. So first of all, there's another streaming service called Interactive Video Services, and it actually provides um, a solution that allows for more of like a social streaming experience. Actually, very
Mm.
synonymous to SteamYard. They just recently deployed WebRTC support for their particular solution. I don't know too much about that. I believe that Chime also uses WebRTC. I'm not a Chime
Mm-hmm.
specialist, so I'm just kind of going off of things that I've heard. And then WebRTC is used by, I think another couple of services that are out there. But I think maybe the more interesting thing that I've been exposed to recently, even though it's still in progress, Amazon as a whole is part of the CSA Alliance, the group that's putting together the Matter standards. And while I'm not directly contributing, I'm fortunate enough to just be included in some communications between our team members that are meeting to discuss the spec. What's really cool so far is to see that WebRTC is being considered kind of front and center when we talk about Matter support for cameras in the future. So still more work to be done there. The spec is not finalized by any means, but I do think that it's telling that when we think about, hey, how do we provide like a standards compliant way to provide video streaming for all sorts of connected devices out there through the Matter spec, that WebRTC is right there front and center.
Okay, so in the space of connected home, then together with potentially a new specification for Matter, the new version of the Matter spec, then there will be camera support and WebRTC support and better specified. Is that what we're saying?
I hope that's what it's going to be, but like I said, we will see.
I see. And I also know that there is a Flutter SDK for WebRTC as well, right?
Yeah. So you don't have to use our SDKs to connect to AWS services, the WebRTC services that Kinesis Video Streams provides. I have customers that are connecting using Flutter SDKs that are just publicly open source and available. I've also seen customers find Golang-based WebRTC libraries, Rust libraries. And so the nice thing about KVS and WebRTC is it's a standards compliant build. You can bring whatever SDK you really want to. The only nuance there is the WebRTC spec includes the notion of a signaling service, but is not specific in how that is to be implemented. Now, many solutions that are out there implement the signaling service back and forth as a WebSocket connection, which is what we do as well. And so that makes it very easy, again, for just kind of these open source libraries to build a standard way to do it. But I'm mentioning this because if you bring your own SDK or library and connect to KVS WebRTC, you may just still have to make sure that you're connecting to our signaling service so the devices can communicate with one another over a WebSocket connection. And then we do have well-documented WebSocket APIs and make sure that your client's adhering to that. That is what our SDK does. It's encapsulating that whole interaction for you and making that easy to get started with.
I see. So basically, you can use open source tools as well, but then you would have to do a bit of heavy lifting on your side when you're integrating these open source tools.
Yes. Yep.
Right. And what happens with embedded devices, and what happens maybe with real-time operating systems like FreeRTOS and KVS? Is there any KVS support for FreeRTOS?
Yeah, so today there has been some projects that have been created by some other solutions architects here at AWS. There is a repo that shows an example of how to include the KVS WebRTC SDK for C into a variety of FreeRTOS projects. The challenge with working with a lot of MCU is that they won't necessarily have the capability to perform the encoding necessary for the media to be transmitted across that WebRTC peer connection. But there are some interesting advancements coming out for that as well.
Okay, yeah, that's actually that's interesting and good to know. Okay, I mean, there is another thing that I'm actually curious about, right? So when you're thinking about a lot of videos and a lot of video streaming from a lot of cameras, this sort of solution at scale. Can you tell us a little bit about the cost? And here I don't mean, the exact pricing and so on, because of course this can be optimized and everybody can, lower the cost by building something that's scalable and so on. But a little bit about the ballpark of the cost, and maybe base it on what you showed us today in your demo.
Yeah. So from a WebRTC perspective, there's like a general expected cost of could be a couple cents per device per month. If you're connecting through our turn server to relay the media, that's probably one of the larger pricing considerations. But today, again, peer-to-peer, if that kind of connection can be established, it really kind of bypasses the cloud altogether. It really just allows devices to connect to one another. So the cost is just for the devices connecting to that signaling channel, exchanging some messages, and then, like I said, if it needs to fall back to turn, there's a pricing component for that. So it can be as cheap as a few cents per month per camera, up to maybe like $1 or so per device per month, kind of depending on usage and things like that. For streams, that kind of depends on how much video you're storing and for how long. So in the clip-based example, for just uploading clips that are captured on the camera device, stored for between 7 and 30 days, which is typical for connected home type customers, really the pricing actually is the same as S3 public pricing, standard tier pricing. And so it's, I think, 2.3 cents per gigabyte per month. So again, like kind of depending on how much video you're pushing through. But I have customers today that are trying to meet this price point that allows them to provide subscriptions to their customers that are, again, only a couple dollars a month. So the product that we have is kind of in line with that.
Okay, thanks. I think that's perfect. Gives us a bit of an idea on the ballpark that we're talking about. Okay, I mean, is there anything else that you would like to share about streaming or about Kinesis video streams or about WebRTC that we haven't covered so far?
Yeah, there's quite a few features that we just didn't get to cover today that have to do with what to do with the media, like how to apply computer vision to things. We don't have to go into all those details today. If you do visit the workshop that we mentioned, this does get into handling some of those integrations. We have support for automatic extraction of still images that are coming out of your video stream. And so there's a transcoding server component that KVS runs that will either do it automatically, or you can do it on demand and go back in time and say, hey, get me some still images from that time. And those still images would be extracted to an S3 bucket of your choosing, and could be used to just show like a preview frame in your application, or to easily build an integration with either AWS managed ML components like recognition images, or to build your own kind of CV processing using your own favorite ML framework. And then we have integration with Amazon Recognition Video through what's called streaming video events. And that's a managed component that can automatically help you detect people, pets, or packages. So all sorts of other things that you could do within KVS, but I would be remiss if I didn't mention the ML side of things.
Yeah, no, absolutely. I think that's actually good, especially because we talked about use cases, right, and customers using it in autonomous driving, for example. And I know you mentioned to me once about a use case involving tractors, which was also quite interesting and quite novel. Maybe you can share that use case as well.
Yeah. So in addition to automotive customers, there's autonomous tractors manufacturers out there, and the surprising thing was to run into quite a few of those. Some of the bigger names like you'd expect, and then there's some more startup style autonomous tractor manufacturers that exist. So same kind of deal with automotive, multiple cameras on the tractor. Tractor is being built to operate in an autonomous mode, has multiple cameras on it. The kind of cool thing about the tractors is they operate more like a their own mini multi-compute center. I don't have a better term for it, but long story short, multiple cameras with multiple like physical devices like Intel NUCs, and then they have maybe a centralized system that's obtaining the media from each of those cameras, and it's also way more compute capable, maybe has a GPU on it as well, to not only record HD video, but to run ML inferencing, obviously to support the autonomous mode, but also to help offload and handle the northbound connection to and from external viewers. And that's where we implement WebRTC as well, so that just in case someone wants to check in and see how things are going, they can bring up the low latency live view of that whatever camera they want to view on the tractor. Same thing with ensuring something may have gone wrong. Maybe the tractor got itself into a situation that it doesn't know how to handle, right? Ran into large boulder in the middle of the field. I'm just making stuff up. I'm not sure if this really happens, but maybe someone ran in front of the tractor, right? And all of a sudden you get an alert like, oh man, a person just went in front of the tractor. Let's go check. Make sure we didn't run that person over. Where are they? Maybe even shout at them like, don't run in front of the tractor. So yeah, there's all the same types of things being done in automotive, very synonymous with autonomous tractors. Really cool to see some of this stuff happening.
Yeah, I think it was a really interesting use case. That's why I wanted to ask you about it again. And another thing that I find really interesting, I was looking through the workshop right now, the integration with AWS IoT and with the IoT core credentials provider service is also really interesting. So maybe we could briefly go over that flow, because I think it's a flow that actually a lot of developers are not very familiar with, obtaining credentials to use for other AWS services.
Yeah, let's see if this image, does this look good enough for us to kind of read through? This is just taken directly from the AWS docs. Actually, I might have modified this just a little bit to plug in KVS proper, but AWS IoT Core provides something called the Credentials Provider Endpoint. And this allows you to take devices that have been provisioned as IoT devices, using something like an X509 certificate as the principal that it uses to authenticate to IoT Core. It made a lot of sense because customers were saying, hey, can we just use that same principle to authenticate directly to other AWS services? So it's very common to think like, hey, I might want to invoke maybe my own API right from the device if the device can handle it. But in this case, we want to treat the device like an IoT device, manage it, maybe even build it to have device management capabilities through AWS IoT Core services to push firmware updates to it, just to monitor the device, things like that. But then we also want to use that same principle on the device to authenticate it to the cloud and to particularly Kinesis video streams. So this whole interaction is already pre-built. Both the producer SDKs and the WebRTC SDKs have support for this integration. It just requires a little bit of configuration. But ultimately, this is like the correct way to think about managing devices at scale as well. Because getting started with the SDK, it's very easy to look at it and say, oh, I can just give it an AWS Access key pair. There's a number of reasons we shouldn't do that. But one of the most important ones is simply like, yes, security, but then also scale. There's a limit to the number of those AWS Access key pairs you can have out there. These X509 certificates, mutual TLS authentication, all the goodness that comes with using them with AWS IoT Core, plus now I've got the ability to scale my fleet of cameras to a much, much larger scale. And then again, using something like device management, I have the ability to really manage that effectively as well. So this integration's a good one to think of if you're thinking through building your own camera fleet.
Yeah, that's really interesting, and I think this sort of integration is quite useful also in other use cases, like you mentioned, wanting to call AWS services from devices directly, making those API calls. So yeah, it's really interesting, really cool. All right. I mean, we are getting, closer and closer, unfortunately, to, to the end of our episode today. But I do want to ask you, David, for the developers who want to get started, maybe we can do a brief summary of the tools that they can use and where they can get started. I mean, I think here also with streaming, but with WebRTC as well.
Yeah, absolutely. So the workshop I mentioned, great way to get started. The Kinesis video streams developer guides also provide great detail on how to get started. The links to the SDKs themselves contain really a lot of what you need just to get started on the device side of things. The sample applications that are provided with the SDKs are easy to compile and get up and running with. But if you run into any trouble, again, my name is Dave Malone. Feel free to reach out, connect with me on LinkedIn. The other place to potentially seek help is Amazon's repost or AWS's repost. That's a good place to go and post your questions. There's quite a few of us worldwide that are looking at that for KVS type questions and trying to respond as quickly as possible just to help customers get unblocked there.
Mm-hmm. Yeah, and actually repost is very interesting. It's really a tool you can use for most of your IoT related questions. So of course KVS related questions, but also just general, more generic questions on IoT core and device management, or even embedded questions, RIATOS, any kind of issues you have with IoT. So thank you for bringing that up. Yeah. So do reach out to David if you have, any kind of questions about KVS, if you're trying to build something and, like always, if something doesn't work, if he can give you some advice or some help in the space, that would be really, reach out to him. That would be really nice. And what about, do you have any kind of sessions, David, coming up, like webinars maybe, or are there any videos available on streaming, or any sort of presentation sessions, demos that you are planning in the future?
Yeah, we have a couple of sessions that have been recorded by some of my peers out on YouTube. There is an AWS IoT channel where some of my peers' videos are posted for getting started with Kinesis video streams and RTSP streaming. Those might be of interest. And then we are going to try to plan a more public kind of walkthrough of the workshop with kind of multiple customers that want to come in and participate in that and have us to come alongside them and support them. We're going to try to target a little bit later this year for that. And then, of course, we're supplying a number of submissions for reInvent for WebRTC workshops. This year, we hope to actually also provide, through our partner network, actual hardware to build a camera, get it connected, and incorporate it in your own account. Still a little bit of work in progress at this point, but that's what we hope to deliver at reInvent this year.
Wow, this is really cool. So yeah, reInvent is coming, is getting closer and closer. So if you're attending reInvent, keep an eye on sessions and demos with WebRTC. And sure, if you can get your hands on some hardware and build something live, that would be really cool. All right. Well, thank you very much, David. Any last words for today?
Yeah, I would just say if you end up building something with Kinesis video streams, I'd love to hear about it and love to see it.
Very good. So do let us know if you're building something with KVS. In the meantime, thank you very much again. Thank you, David, for joining me today and for talking about KVS. It's been really interesting. And thank you for your demo as well. Very cool stuff. And for the IoT builders out there, I will see you and you will hear me next week in a new episode. We are always live at 8 a.m. Pacific time, 17 CST. So yeah, see you then. And in the meantime, keep building. Bye.
Bye.